Hi everyone, my name is KHAMESH. I'm a third year undergraduate student of Engineering Physics of IIT Roorkee. In this video, I'll be telling you about the LDR, which generally contains a photoresistor and which also acts as a passive component in the LDR. In this PPT, we will first understand that what do we exactly mean by an LDR, and then subsequently we will understand how does a typical LDR work. And after understanding the working of LDR, we will classify the LDR on the basis of the type of material that is being used. And then we will try to apply the LDR characteristic in real life problems. And eventually we will conclude our presentation with advantages and disadvantages of LDR. So we first have to understand what exactly is LDR. So LDR is basically nothing but just a resistor whose resistor can be controlled by that light, or its resistance changes as the intensity of light falling on an LDR changes. The effect of light intensity on an LDR is that the resistance gets lowered in value as the light intensity increases. It has been noticed that in many LDR, in absence of dark, that means that there is zero intensity of light, the resistance value could be in several mega ohms, while in the presence of light, when there would be some intensity of light present, the resistance can have value as low as few hundred ohms. On the right side, what we can see is there is a symbol for an LDR, and on the left we see how an LDR looks like. It basically contains a material which we will discuss about in subsequent slides, which is mounted on a surface in a zigzag pattern so that we could have as long length of material as possible. When it comes to the suitable material that should be used in LDR, then the semiconductor materials are the ones that we look for the construction of an LDR. Sensitivity of an LDR varies greatly with the wavelength of light incident upon it. There may be some photo cells which does not respond in change in resistance at all for some certain range of wavelengths. Now we'll see the basic principle behind working of an LDR. So whenever a light is incident on a photoresistor and it has a certain minimum frequency which is decided by the band gap of the material, the photons of light get absorbed by the electrons, and the transition of bound electron from valence band to conduction band occurs. This transition results in increase in number of electrons in conduction band, and hence the additional electrons that are produced helps in conducting electricity, and thereby the resistance of an LDR gets lower. And that's what the basic principle of LDR is. In this slide, we have shown how the graph of resistance will look like with the intensity of light. As we can see that in the absence of light, that is in darkness, the light intensity is nearly zero. The resistance value is quite large. It is in several mega ohms. But as we increase the intensity of light resistance decreases, and we can see in bright sunlight the value of resistance in some ohms, some 2-digit ohms. The LDR can be classified into two types on the basis of the semiconductor that is being used, and they are intrinsic and the extrinsic. As the name suggests, on the basis of our basic knowledge of semiconductor, the intrinsic is the one in which no additional impurity is added and it only has its own charge carriers, and that also become one of the reason of it having very low sensitivity and efficiency. Pure semiconductor materials like silicon and germanium are used in this intrinsic LDRs. While on the other hand, extrinsic is the one in which a semiconductor having additional impurity is added. It is also the impurity that is being added is also called as dopants. Here, the ground state energy of the added dopants is closer to the conduction band, so the electron do not have to jump much farther as compared to the intrinsic LDR, and thereby lower energy photons are also sufficient to trigger this kind of device. Now we will see the two most widely used application of LDR. Here the first one is application in automatic street lights. So what we want here is that the street light to work only in night or evening times whenever there is darkness. This can be done by placing the LDRs in street lights, and whenever light is detected through LDR, that street light gets turned off. By this way we can save a huge amount of energy. The second application can be in fire alarm. So whenever there is an absence of smoke light, intensity would be more, and in presence the light intensity gets decreased, and by this fact we can calibrate our device by placing an LDR so that whenever there is low intensity, the fire alarm starts ringing. There exist both advantages and disadvantages of a device. So is with the LDR. The best thing about LDR that they are not much expensive and they are easily available in the markets, and they are also quite small in size, and they don't need complex circuits and connections. LDRs also don't need high power and voltage source for its operation. Now coming to the disadvantages, the biggest disadvantage of LDR is its slow response time, and it could take around tens of hundreds of milliseconds to respond to the change in condition of light intensity. Also, the resistance of LDR changes as the temperature changes, so it kind of becomes temperature sensitive, and we don't want that because it will start giving us false results whenever the temperature condition changes. With this, I finally conclude my PPT on the LDR, and thank you.